Okay, section 1.5. We're going to work on these learning targets today. I can find the domain and range from a graph. Yours actually isn't listed there, but we will be doing that. So if you want to add it, go ahead. Use the vertical line test. We've been using the vertical line test in section 1.4, so that'll go quick and easy. And we'll stop today at finding the zeros of a function, which it's really just kind of described a little bit differently, but we actually did those steps as well in section 1.4, 1.3. Okay, so the vertical line test simply says if no vertical line can intersect at more than one point, then we're good to go. We say it is a graph of a function. Okay, so which of the graphs below represent a function? This one does. I can draw a bunch of vertical lines, and it's only intersecting at no more than one spot, right? Okay, so does it represent a function? We say yes. Just a short little justification. I'm just going to say passes VLT. Okay, we all set there with part A? Like I said, we've already reviewed this year. B, this does intersect at more than one spot. So no. Okay. Does not pass VLT. Okay, so that's what we do for an explanation. These last two, I'm just going to give a quick yes or no. We can draw some lines here, right, that intersect at more than one spot. So no, not a function. And this one does. I know this one starts to bend vertically, but it's going towards what's called an asymptote, so it's still going to bend ever so slightly. So we'll never get actually straight vertical, so it's still going to pass the vertical line test, one spot at all possible spots. So yes. Okay, any questions on number one? Okay, now I know we've defined domain before, but let's kind of write a new way to interpret this when looking at graphs. So here's really the question you want to ask yourself for domain. Okay, so here's what I want you to write down. For what x values does the graph exist? Okay, that's the question you want to pose on yourself. For what x values does the graph exist? And for range, let's just keep that same format. For what y values does the graph exist? Okay, so notice the key difference in that. Might seem like you just did the same thing, and you did, except with, for the exception of one saying x, one saying y. Okay, so let me give you a quick little example of this. We'll just fit a graph in here. I'm going to call this an example. At an x value of -2, I'm going to start with a solid dot and just do like kind of a half parabola type thing or something like this. Okay, so just make that simple graph. Okay, so we want to ask ourselves, for what x values does this graph exist? So I've got to remember x is going left to right. This is my x-axis. Okay, so we could say this: for all x that are greater than or equal to -2. Okay, so when x is -1, the graph exists. When x is 0, the graph exists, and so on. But when x is -3 over here, it doesn't exist. Okay, now we are going to start using interval notation much more moving forward. Okay, so I'll also add some things about interval notation below. You know, I'll come back to it. Let's just leave it. So I'll go over the rules of interval notation. I'll come right back to it. All right, so the domain's all set. What about the range? Okay, the range for this graph, now I want to look at this thing vertically. How high and how low does it go? Sometimes turning this sideways helps students see it. Okay, so looking at this y-axis, it's never negative, right? It starts at a y value of 0, and then it continues on upwards to positive infinity. Okay, so for the range, we would say y is going to be greater than or equal to 0. It's one of those things I can't show you algebra steps for. We got to view the graph. I can give you some hints on how to look at it. but we got to see it, and we just got to practice it. Okay, now expressing these in interval notation, let's go ahead and solidify these rules that you were taught in Algebra 2, and then we'll answer it that way. Here's the rules. Let's get used to interval notation. It's a lot easier than the inequalities. Okay, this reads parentheses. Parentheses indicates endpoints that are not included. Okay, parentheses indicate endpoints that are not included. We're also going to use what we're going to call square brackets. Square brackets indicate endpoints that are included. Okay, and one other little rule, and then we'll take a look at these. For negative infinity or positive infinity, and it's kind of a side words of 8 for those symbols, you always use parentheses because that's a number you can't really capture anyways, and so because of that, the rule is to always use parentheses. Okay, let's squeeze in a couple examples down here. All right, so here's an example. Why don't you write this down? Part A. X is greater than 1 and less than or equal to 6. There it is in what's called a compound inequality. To convert this to interval notation, let's follow our rules. Think of like a number line. What's the lowest number in this inequality? Obviously 1. So interval notation always goes from least to greatest. And I don't want to include that. This says X is greater than 1, not including 1. So I need to use parentheses for that. So I'm going to do parentheses 1, comma, and then the endpoint of 6 is included. Okay, less than or equal to. So when I put 6, and now I need a square bracket to indicate we're including that endpoint. Okay. Let me show you a different one. Let's say it said X is less than or equal to 5. You know, on your number line, you don't necessarily have to include this if you don't want to, but I'm just giving you a little visual aid, right? Would be at 5 with a solid dot, and then it's going this way. So what's the smallest number on this number line? Well, we can't really pinpoint it, but we can say negative infinity. So negative infinity all the way up to 5, left to right format. So parentheses, negative infinity, up to 5, and I'm supposed to include 5. So bracket. Okay, so coming back to you. I remember doing this last year. Okay, good. Just wanted to clean it up a little bit. Okay, so here we go. I'll back up to that domain problem I gave you. X is greater than or equal to negative 2. So on a number line, now it's going the other direction. Here's negative 2. I've got a solid dot going this way. So that's my left endpoint. So I'm going to say bracket, negative 2, and it carries on to positive infinity, parentheses. Try it for the range real quick. Go ahead. All right, bracket 0 to infinity. Okay, remember, if I don't have a line underneath it, so just y is greater than 0, meaning that would have been an open circle. Now I'd have parentheses 0 to infinity. Okay? All right, next page. Okay, so we're going to use this graph right here start practicing this, finding the domain of f, find the range of f, and then this is just function notation and reading graphs. We're finally getting into some pre-calc skills. This is some pre-calc skills. Evaluate the function when x is -1 and when f is 2. Okay, let's do that right away. Let's go f -1. I'll just put it right over here. So f a -1. And then we also want to find f of 2. Okay, remember, your input values in a function are x. This is in that spot of our f of x notation, right? F of x equals y. So we're giving the x value. We need to go to the graph to find the y value. Okay, so when x is -1, here's an x value of -1. Where does the graph exist at? Somewhere down here, right? So if I follow this line down, looks like the y value is right here. So when x is -1, y is -7. Okay, that's the answer to that part. They're asking us for 4 different things. Okay, what about when x is 2? Well, when x is 2, here's my x value of 2. Look up and it looks like the corresponding y value is a value of 1. Okay, so those are the answers to that part of the problem. Zoom it out in case you can see it. There it is. Okay, so the domain. I'll just put it up here, capital D. All right, for what values of x does this graph exist? Now, when sometimes these computer programs, if they slide the graph off the coordinate plane a little bit, they want you to assume that it keeps going. So if you want to add arrows to this, that would be appropriate. It's basically an upside down parabola. So the domain does continue for all x. I know it's kind of hard to imagine, but it's going to continue at this slight angle forever and ever, even when x is way out here at a large number like a -1,000,000. Okay, so from -x to +x, this graph has a y value. It's going to exist. All real numbers. This continues in both directions forever. Okay. The range, not so much though. It has a maximum value right here, right? When y is 2, it doesn't have a graph. This is where turning it sideways is going to help you. Maybe, but at least for a good teaching tool, right? The graph stops at a y value of 1. Do we think we should include 1? Yeah, I do, because remember, a line is a continuation of solid points. So we should include 1. Okay, so anything less than a value of 1 works. Okay. All right, so remember, we're starting here with smaller values, so -infinity up to 1. I don't know if that confused you because the number line was turned around. Maybe I should have turned it this way. So -infinity up to 1. And include it. Okay, pause this and let you try number 3. All right, here you go. Here's your feedback. When x is -1, what's y? That's what this is asking for. So when x is -1, I track this down, the y value. This is going to be off a little bit, maybe from people or person to person, but -1.8-ish looks like a good answer, right? We go across. So about -1.8 or -1.9 would be the corresponding y value. Okay, so I put the squiggly here for approximately. When x is 2, what's y? So here's an x value of 2. Find where the graph exists. Looks like that's probably right around 2. All right, for what values of x does the graph exist? For a domain. So it kind of has like walls, right? So from left to right, it's fenced in right here to here. And then when we go to range, we'll fence it in up and down. Okay, so what values of x does the graph exist? We can't include -2. Okay, it begins like at -1.999. Don't jump to -1 because we do want to include numbers like -1.9. So how we account for that is the parentheses. Parentheses -2 is the left endpoint, and then it continues on to this +3, and we should include it. So there's the domain. Okay. Range, now I'm thinking top and bottom of it, right? So I've turned this thing to the side. So what's the lowest y value I have? -2, not including -2, all the way over to 4, including 4. Okay.